Okay, so welcome back, and so now let's give the definition of a telescoping lens. Telescoping series. So, telescoping series is, again, a series in which most of the terms cancel each other out except for, well, let me rephrase that. In each of the partial sums. So, in a series of, a telescoping series is a series in which most of the terms in the middle will cancel each other out, except for some terms in the beginning and some terms at the end. Okay, so that's the definition of a telescoping lens. Okay, so if you take each of the partial sums, you'll see that what you'll end up with is some terms in the beginning and terms at the end, and all the terms in the middle will cancel each other out. So for example, if we take any sequence, any series of this form, where we're taking one term, right, and we're subtracting off another term. So in this form, right, what we're doing is we're taking b sub n and we're subtracting off the next term, right? So any series of this form is going to be a telescoping series. And you can see this by just looking at the expansion. You see that you have a minus b sub 2, and then you have a plus b sub 2, a minus b sub 3, plus a b sub 3, and so on. So if you look at the partial sums, S1, you just get this term, right? B1 minus B2. S2, you get the first two terms, but then you get a minus B2 and a plus B2 here. And they cancel each other out, and so you get B1 minus B3. For B3, same thing. You get the first three terms, right? You get the first three terms, and then what happens is you end up canceling. The B2s cancel, the B3s cancel, and you get B1 minus B sub 4. So in general, what happens is you end up getting something like this, because the kth partial term, or excuse me, partial sum rather, has this form. S sub k equals B sub 1 minus what? B sub k, right? So for each one of these, you end up with B sub 1 minus the last term, which in this case is B sub k. Okay, now, in this case, when you have this case, oh, I'm sorry, should be k plus 1. I forgot about that. It's k plus 1. Okay, now, the determination of the convergence or divergence of this series, or of the partial sum rather, is contingent not on the first term, but on that last term. Okay? And so, the kth partial sum can be simplified to a difference between these two terms, and the sequence of the partial sums will converge if and only if the sequence of the last term converges. Okay? So really, it depends on, so this sequence, so in other words, the sequence of partial sums, S sub k, whether it converges or not, really depends on the sequence of the last term, right? Whatever form that term takes. If that sequence of that term, right, converges, then the sequence of the partial sums will converge. Now, if this converges, then it's going to converge to some number, right? So if this converges to some number b, then obviously S sub k is going to converge to what? It's going to converge to b1 minus b. right? So that's obvious from our discussion that we've had. Okay, so now let's do an example and see how this thing works.